All right, hopefully this video is mostly a review for you. What we're going to look at is the atomic mass and atomic number and kind of the basic structure of an atom. So this is called the nuclear notation because more than anything else it tells us what's inside of the nucleus. The top number, which is always the larger one, is our mass number. And so that's going to be the total mass of the atom in AMUs. And it's the number of protons plus the number of neutrons. The bottom number, the atomic number, is just the number of protons. If it's a neutral atom, it'll tell us the number of electrons as well. And so by subtracting this number from that number, we can get the number of neutrons. By just looking at that number, we get the number of protons. So, for example, from this picture right here, we can see that carbon, since it's got an atomic number of 6, has 6 protons. Since it's neutral, we know it's neutral because there's nothing up here in the top corner. You guys know that's where we put the charges. That means it's got to have 6 electrons. And the top number right here, the mass, is 12. That means there's 12 things making up the mass. We know that there is 6 protons, and so where does the other 6 come from? Well, it has to come from the neutrons. And so there's going to be 6 neutrons. All right, and also make note, we do call these numbers the A and the Z number. And that is something you need to memorize, because what you're going to see on questions, they're going to say something like a particular atom, Z equals 35. And you need to recognize, okay, Z, that's atomic number. So if Z is 35, it means 35 protons, and so this atom is bromine. They're not going to tell you the identity of the atom. They're not going to tell you 35 protons. They'll just tell you Z or A. And this is standard chemistry convention. This slide right here probably looks almost identical to the last slide we just looked at. However, if you take a close look, you're going to see that this is carbon-14. It has a mass of 14 instead. Number of protons is still the same, and that's what identifies the element. So since it has 6 protons, it has to be carbon, but now it has a mass of 14. So whereas the last one had 6 protons, 6 electrons, and 6 neutrons, this one right here, 14 minus 6, is going to have 8 neutrons. And we call this an isotope. An isotope is an element that have the same atomic number, so they both have 6 protons in this case. However, they have a different number of protons and therefore a different mass. Some quick info on isotopes. Isotopes of an element, same number of protons, different number of neutrons, different mass. They have almost identical behaviors. And that's why, you can have H1 or H2. Both of them will bond with oxygen to form water. If you go out into the ocean water, you're going to find a certain percent that's H1, certain percent that's H2. Carbon-14, carbon-12 are both going to form carbon dioxide. Both of these will exist in nature. However, there is the matter of relative abundance. So although H1 and H2 both exist out in nature, you're going to find much more H1 than you do H2. Okay, there's going to be a smaller percentage, and we'll talk about that in the next video.